So another problem based on the above results here is prove that sin inverse 4 by 5 plus sin inverse 5 by 13 plus sin inverse 16 by 65 is equal to pi by 2. Okay. Now, in order to solve this, start from the left hand side. Okay, you take the first two sine inverses. Okay, sine inverse 4 by 5 plus sine inverse 5 by 13, and you add them by sine inverse x plus sine inverse y formula. So if you have sine inverse, that is, you are taking these two you're taking together. Okay, so you're getting sine inverse x root 1 minus y square plus y root 1 minus x square. Okay, if you combine the first two sine inverses, and this one you leave it as it is. In the next step, you simplify this result. You have 4 by 5 and root over of 1 minus 5 by 13 whole square. If you simplify, you will get 12 square by 13 square, which is simply 12 by 13. Okay, plus 5 by 13. Again, here you simplify 1 minus 4 by 5 whole square. You will get 3 by 5 plus sine inverse 16 by 65. And now you have sine inverse. Now, if you multiply all this, you will get this is 48 by 65 plus 15 by 65 plus sine inverse 16 by 65, which is sine inverse of 48 plus 15 will be 63 by 65 plus sine inverse 16 by 65. Now you combine these two sine inverses by sine inverse x plus sine inverse y formula into a single sine inverse. You get 63 by 65 root 1 minus 16 by 65 square plus 16 by 65 root 1 minus 63 by 65 square. Okay, so this now you simplify 63 by 65. Okay, so you get here, let me show you a little bit of simplification here, since this is not, you're not very acquainted with these squares. If you take the LCM here, 65 square minus 16 square divided by 65 square plus 16 by 65 root over 65 square minus 63 square divided by 65 square. So this is sine inverse 63 by 65, and 65 square is 4225. 16 square is 256 divided by 4225 plus 16 by 65 root, again 65 is 4225, and 63 square is 3969 divided by 4225. So you have sine inverse 63 by 65, and root over of this, if
63.
this is, I think, 4225 minus 256 will be 3969
Yes, sir.
divided by 4225 plus 16 by 65, and square root of this should be 256. 4225 minus 3969 is 256 divided by 4225. Now what you see under the radical, all these 3969, 4225, 256, all these are square numbers. So you can write these as 63 by 65 square root. 3969, if you want to find out the square root, you will find this to be 63. Okay, the square of 63 is 3969, and this is already 65, we know.
Yes, sir.
16 by 65, and this is again 16 by 65.
65.
You close the box brackets, and you have sine inverse. Now you see that you get 63 by 65 into 63 by 65 plus 16 by 65 into 16 by 65. So this is sine inverse of, now 63 into 63, you can find this out to be 3969. This you know as 4225. Again, this is 256 by 4225. Okay. So now if you take the LCM here within the box bracket, you will get 4225 by 4225, which is equal to sine inverse 1. Sine inverse 1, you know, is how much? Sine inverse 1 is pi by 2, because sine pi by 2 is equal to 1, and which is equal to your right hand side. Okay, so that is how you do this sum. So all the results are now over. Okay, now this time to show you only the solved examples, some variations in the types of problems that are given. Okay, you do these variations, all the problems in the exercise will be some variation of these problems that I am doing. All the problems in the exercise. Okay, so, so let's to do this some exercise problems. First one is, let's say, problem. Question here is evaluate tan half cos inverse root 5 by 3. Okay, this is the problem. So what you see is, if you have to evaluate this, see, this tan contains all this, right? This tan contains all this. If this tan contains, if in this entire thing can be converted to a tan inverse, then we'll get tan of tan inverse, isn't it? Isn't it? So that these two tan and tan inverse will nullify each other. So we try to express this as a tan inverse, this part within the box. Okay. So what I do is I start by saying, let this part within the box be equal to theta, and then we can start. So we start by saying let half cos inverse root 5 by 3 equal to theta. So that means you have cos inverse root 5 by 3 is equal to 2 theta. That means you have cos 2 theta is equal to root 5 by 3. Now what you see here is that, as I told you, this has to be expressed in terms of tan inverse, right? Now see, I have got cos 2 theta. Now this cos 2 theta I want to express in terms of tan. So what is the formula for cos in terms of tan? You know this formula, tan square theta is equal to 1 minus cos 2 theta
1 plus cos
by
2
1 plus cos 2 theta, right? Why am I using this formula? We are using this formula because this is cos inverse here. We want this cos inverse in terms of tan inverse. So you want a relation between cos and tan. That is why we are using tan square theta is equal to 1 minus cos 2 theta by 1 plus cos 2. Is that clear?
Yes, sir.
So what we'll
Yes,
do
sir.
here is we'll put cos 2 theta as root 5 by 3, and this is 1 plus root 5 by 3. Now you take the LCM here, you get 3 minus root 5 by 3 plus root 5. Now what you do here is you rationalize the denominator. 3 minus root 5 into 3 minus root 5 divided by 3 plus root 5. That is multiplying the numerator and denominator by 3 minus root 5. Okay, so what you are left with here is 3 minus root 5 square divided by 9 minus 5.
5, 4.
So you get 3 minus root 5 by 4. 3 minus root 5 whole square by 4, which can be written as 3 minus root 5 by 2 whole square. Right? So you're getting tan square theta is equal to this. That means what is tan theta? Tan theta
And
is
theta
3
is
minus root 5 by 2 simply.
5.
Right? Okay. So we'll not take the negative sign because see, why we are not taking the negative sign, why we are not taking plus or minus? We are not taking the plus or minus because see that this here, the value here is positive, right? And we want tan also to be positive. Okay, because cos is positive here, the value of cos is positive here, which is root 5 by 3. In which quadrant is cos positive? In the fourth quadrant. Okay, and here tan in the fourth quadrant, if it is positive, and tan is positive in which quadrant? Tan is positive in the third quadrant, right? So therefore we take only the mm, uh, positive value. In fact tan and cos are positive in the first quadrants, right? Tan and cos both are positive in the first quadrants. So therefore we take the solutions only in the first quadrants. Okay, we take only the positive values. So that is why no question of fourth quadrant, only the first quadrant. So root 5 by 3 cos is positive, tan is also positive in the first quadrant. So therefore theta we will get as tan inverse of 3 minus root 5 by 2. So therefore what have we done? So thus what was the value that we had to find out? In the question it was given, find the value of tan of half cos inverse root 5 by 3, which we just wrote as tan theta because we took half cos inverse root 5 by 3 as theta. And we have also shown above that tan theta, the theta is equal to tan inverse of 3 minus root 5 by 2, which is equal to 3 minus root 5 by 2. That is your value of the expression. Any question?
No, sir.
Let's prove the next result here then. Next problem actually. The next problem here is prove that the next type of problem, prove that tan inverse root 1 plus x square plus root 1 minus x square divided by root 1 plus x square minus root 1 minus x square is equal to pi by 4 plus half cos inverse x square. Okay, this is what you have to prove. Now, this is a little different type of an problem here. This is just a slight variation. In fact, an important variation, because this kind of an idea, if you have, you will be using this kind of an idea in your differentiation also. Okay. See, now you have a tan inverse here. Okay. You have tan inverse of all these within this bracket, right? Now, if I want to convert everything this to a tan, right? Because if I can convert all this to a tan, then it will become tan inverse of tan, and then we'll get the value. But how do you convert? See that tan, if I want to convert all this to a tan here, that means tan has to be written as 1 plus something divided by 1 minus something, right? And what do you know? We know that tan square theta is equal to 1 plus cos theta, cos 2 theta by 1 minus cos 2 theta, isn't it? This is what we know, right?
Yes.
So, but if we, but there is no one here. We don't have a one here. So that means this will not work. What we are, that means this will not work because we don't have a one here. Okay. So therefore, what should come to your mind next is that if I want to express this as tan, then
So we can take x square as cos theta
yes. But why
or
will I
cos.
take x square? That is the issue is why should I take x square as cos theta? Okay, I should take x square as cos theta because see, if I can have 1 plus cos theta here, 1 plus cos theta here, then you know 1 plus cos theta according
2
to
cos
multiplying is 2 cos square theta, 2 cos square theta by 2 in
by
fact, right? And if I can have x square is equal to cos theta, then I'll get 1 minus cos 2, 1 minus cos theta here. That means I'll get 2
sin
sine square
square
theta
theta
by
by
2,
2.
isn't it? Which will be under radical, isn't it? Because there is a radical sign here. So that I'll get root 2 cos theta by 2 plus root
So
2
we
sine
will
theta by 2.
cos theta
Okay, so we'll get somewhat like this.
root 2 common and we'll cancel it.
Yes,
Yes,
we
sir.
can take root
Cos
2
theta
common
by
and
2
then we'll
and
cancel it. And then we'll
hmm.
use a small technique that we used last year in class 11 to convert cos theta plus sine theta by cos theta minus sine theta into a tan. So let us see. This is a little special kind of an example. So let us start with the left hand side. The left hand side is tan inverse root 1 plus x square plus 1 minus x square divided by root 1 plus x square minus root 1 minus x square. Okay. So here I say let x square is equal to cos theta. You can take cos 2 theta also, no problem. Okay. So therefore, that means if I take x square is equal to cos theta, that means theta must be equal to cos inverse x square. So we shall be taking using this a little later, not now. So therefore, what does LHS become? LHS becomes tan inverse of root 1 plus cos theta plus root 1 minus cos theta divided by root 1 plus cos theta minus root 1 minus cos theta. Okay. So which is equal to tan inverse. So root 1 plus cos 2 theta, as I told you, is 2 cos square theta by 2. And root 1 minus cos theta is 2 sine square theta by 2. And by 2 cos square theta by 2 minus 2 sine square theta by 2. So this is root 2 cos theta by 2 plus root 2 sin theta by 2 divided by root 2 cos theta by 2 minus root 2 sin theta by 2. So that if now if you take root 2 common from the numerator and the denominator, root 2 will cancel. You'll simply get cos theta by 2 tan inverse of cos theta by 2 minus sin theta by 2 divided by cos theta by 2 minus sin theta by 2. Now you just need to recall a little bit of your class 11 trigonometry. If you remember this,
Divided by
yes, if you remember, I had shown you this kind of an example where cos theta minus sin theta by cos theta plus sin theta by cos theta minus sin theta can be expressed in terms of tan if you divide the numerator and denominator by cos theta by 2. If you divide the numerator and denominator by cos theta by 2, you get 1 plus sin theta by 2 by cos theta by 2
yes, sir.
divided by 1 minus sin theta by 2 by cos theta by 2. If you divide the numerator and denominator by cos theta by 2, dividing the numerator and denominator by cos theta by 2. Okay. So this becomes tan inverse of 1 plus tan theta by 2 divided by 1 minus tan theta by 2. Now if you remember this technique, 1 can be written as tan pi by 4 plus tan theta by 2 we write as it is 1 minus, and tan theta by 2 can always be written as tan pi by 2 into tan theta by 2, because you know tan pi by pi by 4 into tan theta by 2, because you know tan pi by 4 is 1. You remember this technique back in class 11?
Yes, sir.
Yes, sir.
So tan inverse tan. Now if you see, this is simply compound angle formula, pi by 4. This is tan a plus b formula. Okay. So what we have done is we have got a tan here and we have a tan inverse here. They will nullify each other. So we'll simply get pi by 4 plus theta by 2. And what was theta here? Theta here was cos inverse x square. This one,
Inverse x
right?
square.
We just put this value here. So pi by 4 plus half cos inverse x square. And that is what we needed to prove is equal to right hand side. That's it. Okay. Moving on to the next example from the exercise. The problem here is if a greater than b greater than c greater than 0, prove that cot inverse ab plus 1 divided by a minus b plus cot inverse bc plus 1 by b minus c plus cot inverse ca plus 1 by c minus a is equal to pi. Okay. You need to prove this. Let's start from the left hand side. Left hand side, we have cot inverse ab plus 1 by a minus b plus cot inverse bc plus 1 by b minus c plus cot inverse ca plus 1 by c minus a. Now, since it is difficult to work with cot inverse, we work to tan inverse. That is, we convert cot inverse to a tan inverse. And when you take tan inverse, this will just become the reciprocal. Right? When you convert cot inverse to a tan inverse, it becomes reciprocal. Let's write this as Instead of EB plus 1, let's write this as 1 plus AB, so that it looks a little acquainted form. Tan inverse C minus A by 1 plus C. So now if you remember, yes, Devanjan, Tanisha, you can hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Something went wrong. You can see the screen, right?
No, sir.
You can't see.
It's black.
Okay, screen sharing went off. Fine.
Yes, sir. Now I.
Okay, so as I said, you take the reciprocal, convert cot inverse to a tan inverse, and now it looks like in a quantitative form, right? This looks like your tan inverse. If you remember this, tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy, isn't it? Now, if you see, this looks like this one only. So you get tan inverse A minus tan inverse B, right?
Yes, sir.
Plus this looks like tan inverse B minus tan inverse C. Ideally, you should be putting brackets here, but I'm not putting because I have a plus sign here. Okay, so I'm not putting the
Yes.
brackets. Okay, because ultimately, if you open the bracket, no signs are going to change. So tan inverse B minus tan inverse C plus tan inverse C minus tan
So all will
inverse.
cancel out. 0 will be left.
Yes, that is what. So you will get your what was the proof here? You need to prove that this was equal to pi, isn't it? Um, hmm. So this is oh, actually the question is printed wrongly. This is prove that pi plus. Okay, so now this is okay. So pi plus, you have a pi plus, you have a pi plus, and now this is okay. So this is tan inverse. This will cancel. This will cancel, and these two will also cancel. You simply get pi plus 0, which is equal to pi, which is equal to RHS. Okay, that was a printing mistake in the question. Fine. So let us move on to the next problem and hopefully the last problem maybe. How much time left? I don't know.
10 minutes.
10 minutes. Okay. And hopefully the last problem. Solve. Question here is a little different this time. Solve tan inverse solve tan inverse x minus 1 by x minus 2 plus tan inverse x plus 1 by x plus 2 is equal to pi by 4. Now remember, this is not proof. Okay, this is a solve. This is more of an equation. You need to solve for x. Okay, so you start here. Anyway, so we start here. So we have tan inverse x minus 1 by x minus 2. This is a little long sum, so I think it will be the sum will be carried forward to the next class also. We need to solve this. Okay, so now what you do here is you add up these two by your tan inverse tan inverse x plus tan inverse y formula. Okay, you add up these two. If you add up these two by tan inverse x plus tan inverse y formula, this is what you're going to get. X minus 1 by x plus 2 plus x plus 1 by x plus 2 divided by 1 minus x minus 1 by x plus 2 into x plus 1 by x minus 2 is equal to tan pi by 4 is equal to pi by 4, right? Now in the next step, what will happen is that this here in the numerator, you take tan this side, this will obviously become tan pi by 4, right? On the right hand side. And what are you left with here? You are left with the numerator and the denominator, right? So now you take the LCM here. This is, I think,
So first one, x minus
have I
1 by
copied
x
the
minus
question
2.
correctly? Just let me check if I've copied the question correctly. X minus 1 by x minus 2, x plus 1, yes. Yes, what are you saying? Tell me.
So tan inverse x minus 1 by x minus 2.
Yes,
And
that's what.
plus.
This is x minus 2. So now if you take the LCM, this will be x plus 1 into x plus 2 into x minus 2. So from here, you'll get x minus 1 into x plus 2 plus here you'll get x plus 1 into x minus 2, right? In the numerator. In the denominator, you'll get x plus 2 into x minus 2 minus x plus 1 into x minus 1 divided by x plus 2 into x minus 2, right? This is what you're going to get, right? Now what happens? These two will cancel here. So you simply get x minus 1 into x minus 2, which you multiply to get x square plus x minus 2 plus, and you multiply x plus 1 into x minus 2, you'll get x square minus x minus 2 divided by, you get x plus 2 into x minus 2 is x square minus 4 by a plus b into a minus b formula. And this one is minus x square minus 1 is equal to, you know, tan pi by 4 is clearly 1. Okay, so now you simply cancel what cancels, the numerator plus x minus x cancels, and you're simply going to get twice of x square minus 2. And here in the denominator, you open the brackets, x square minus 4 minus x square plus 1 is equal to 1, right? So now clearly here x square and x square, this cancels out. So you're only left with minus 4 plus 1 in the denominator. Now you cross multiply. So you get twice x square minus 2 is equal to minus 3. Okay, so now you're getting a quadratic. So if you express it in the ax square plus bx plus c form, in fact, no need because there's no x term here. So let's, yeah, you have 2x square minus 4 is equal to minus 3. Still, it remains a quadratic though. 2x square is equal to, you're getting 1. That means x is equal to, x square is equal to half. That means x is equal to plus or minus 1 by root 2, right? This is what we are getting. You have solved for x, but then there are certain additional things. Which value of x should I accept? Whether I should accept x is equal to plus 1 by root 2, or whether I should accept x is equal to minus 1 by root 2. Which one should I accept? That part I'll work out in the next class, because remember, in inverse circular functions, it is not only enough to solve the equation, but you have to check whether your solution that you have got, whether you've got extra solutions or not. Okay, and you need to reject the extra solutions. Understood?